Hi everyone, how are you doing? I'm okay, thank you. I found an issue with the LCD exercise. I was trying to fix it. We'll talk about it. So we'll start in about a minute. If you can get your Raspberry Pi out, you can fire it up and then we'll get started, okay? Okay, so let's switch camera. So today we are going to do two additional exercises, or at least I'll demo those, but you only need to do one more. So a total of 3 for the assignment, and then I'll preview the stuff that you need to do for tomorrow and the rest of the week. The lab is you have actually 4 options, and you are going to pick 2. Okay, and then I'll demo those tomorrow and Thursday. So I'll go ahead and go to screen share here. So I'll unplug my LCD real quick and then we'll swap that. So right now what I'd like to do is um I'm gonna go over the one with the ultrasonic. Okay. So let's okay, so I briefly mentioned yesterday that you are going to be working with the ultrasonic Pi. This sensor is mainly used for object detection using ultrasound. So you often see this being used in robots. Let me change the view here 1 second. Okay, so when you use these, you can plug them directly onto your breadboard, or you can use um, female connection here. And on these, you should see the VCC to trigger the echo and the ground. So you will connect them accordingly. For since we're going to use the 5-volt, you need to use resistors with, and so most of the sensors that you're going to see will be connecting to 5 volts for power. So the VCC is going to go to the positive, which is the power, and then the trigger and the echo is going to be your data. So those are going to go to the GPIO pins, and then your ground is going to go to the ground, either on the breadboard or directly into your Raspberry Pi. So when you put together the circuit, you will need your breadboard, okay, because we are going to adapt the resistors. I did not have 470, so I just used the next closest that I had. It should be okay, but what happened is you're going to see a slight difference in how it's going to output the signal onto the shell. So if you have like 330 and 330, you can plug those in. Something from the last class. How come Arduino does not need resistors for trigger, but the Pi does? So the Pi normally, you don't really need to regulate it if you want it to fully flow. the reason why you do that is over time you don't want to burn out your sensor. On the Arduino, we plug them in directly. You can plug them in directly, and so it's still going to give you the 5 volt, but um, in this case, what you see is because it's analog signal and analog signal is inconsistent, so you want to regulate it um, with resistors. So either way, you don't have to use the resistors, but it's recommended that you use the resistors. So when we did the Arduino activity, we didn't really use resistors. So you can see there how it's being used. And in this case, we're plugging in the same voltage, but because your signal, that's when it bounced back, it's going to be low and high in variance. So we kind of wanted to control the flow a little bit. Okay. So it's just for safety reasons, no big deal. Okay. So, okay. So on this one, I had just used the lower resistors to connect instead of the one that they recommend here in this particular exercise. And so you are going to have a 5 volts that's going to connect to your VCC, which is the first pin that's labeled VCC, and then your data connection. So I would put the male connection onto the breadboard. It's next to, I don't know if you can see this. It's exactly like that. So um, I had connect the cable right next to the pin. And then what you want to do is you kind of want it to make sure that these are going to be um, visible or clear to be able to detect you as you put your hand close to it. And then so I put the positive is my purple. And then so you would just connect that to your 5 volt. Okay. And then on the next one, sorry, on the next two, you would then connect. So I have the green, right, for that. So you would just connect them following the diagram. So the green is going to go to the fourth pin on the left, which is the GPIO 4. So if you're not sure, you can take a look at your card, right? The way the 5 volts is going to be right here. So if you go to the, I just want to make sure. Yeah, if you wanted to go to the fourth pin on the outside, that will be your GPIO 4 or pin number 7. So I'm going to go ahead and do that here. Okay, you can do that while the Raspberry Pi is on. And then my next one is going to be my trigger pin. And that is actually bridge to this so we can control the flow. So what happens is you are going to receive current from here. It's going to go here, and then for the signal for the echo to get back, it's going to come back from the resistor. So with that, what you're going to do is I'm going to go ahead and connect my blue to here. Okay, which is GPIO 17. And so if you look at your chart, you would see that it's after the ground, it's the next one. And then lastly, we can connect the ground, and there's several ground connections. You can connect the ground to the back, the last pin here, like the diagram, or you can connect it in between those. That will be fine. Okay. So after we connect those, we would then, next we can do this by stage. So I'm going to take you to my Raspberry Pi now so I can show you. Oh, again, I think when it's on Zoom, it's not liking it. Let me get to Zoom on this side here. I'm getting a little bit of network issues right now also. Okay, let me stop share on here. Okay, so let's share screen on this real quick. Okay, so here's my script. I had comment out some of the areas because I wanted to run them by stage. So just to run through real quick. So when you look at the instruction, it tells you that first you need to start with these, and then you would do a while true statement and you would see the distance. Keep in mind that originally we don't put the threshold distance in there. So if you put the threshold distance in there, there will be a limitation. So you can put a limit on how far you need the object to be for the range that you want it to detect. So with that, what will happen is first we need to import in GPIO 0. And if you didn't install it yesterday in the first exercise, you need to do that in the terminal. And from this library, you are going to pull distance sensor, which is a superclass. It is a class in that library file, in that library module, and then we are going to use it to create an object called ultrasonic. And on this one, you can name it anything you want. You can say U or ultra or ultra S, whatever. But for the sake of the exercise, we're going to follow the instruction and we can say ultrasonic. And so with this, what we're going to do is we're going to use the distance sensor. And in the parameter for that method, in the parameter, we would need to make sure that we specify our pin. So unlike the other exercise, in this one, we can use the assignment value or the pin value inside the parameter. You can also create a variable on the top and then pass the variable here, but you can use it like this. So for the echo, we would then have 17 and then the trigger is going to be 4. So whichever pin that you connected as a GPIO, you need to say that those are the data pin. And then the third parameter is going to be your threshold distance. Now you can leave this off and it's just going to be operating by the default range. So what you want is you also want to put some threshold in here. So that's what I did. Now, the way that you can do block comment in Python is to use 3 single quotation marks. So if you do that, it's just going to ignore that section of your code. So what I am doing is I'm going to go ahead and remove this. Okay. So what I want is I want it to have an object with the specified parameter for distance sensor. And then I'm going to go ahead and have it print out the distance. So I'm going to turn this toward me and then I can start doing that. So now what we'll do is we're going to go ahead and click run. Oh, sorry. Let me fix the connection. I'm not getting a signal on my echo. Okay. Hold on one second. I'm going to see why it's not functioning. Yeah, it's not reading my module for some reason. So I'm going to do setting sudo app install. Yeah, it's not able to pull my library, so let me go and re-grab the library real quick. So make sure that you have your GPIO 0. Okay. Yeah, I thought I had that. Okay, 1 second. Sudo app install Python 3. Oh, I'm missing a hyphen. There it is. Okay. It's not seeing my echo. Sometime I also plug things in. Let me double check. Okay, 5 volts. That, everything is good. On the ground for the blue switch. GPIO 17. Okay, skip one. So 17 and then 4. Yeah, I don't know. I think it's having an issue with the connection, but when I ran it earlier, it should work. So you should see some kind of value on showing on your Pi shell, it should show like 0.576, etc. when you run after you run the parameter. Okay. Trigger. And rewiring everything, making sure. Maybe I have to replace the resistor. Okay. So when we set this up, we're going to make sure that your trigger and your echo pins are going to be connected. So on here, okay, you wanted the echo and the trigger. And so the trigger, which is pin 2, and the next one is going to be the echo. So the trigger is going to go to 4 and then the echo 17. Yeah, on mine it's throwing errors saying that my echo is not, it's not receiving. So maybe my wire is loose or something like that. Okay, so let's double check. Any questions? Question? So after you have run the first while loop, you should see that it's gonna give you the actual distance. And then let me share screen on this side. So, but before that, make sure that you have this. Okay, if you haven't installed that. And then you will need to run the first while loop. And then after that, if everything, your shell should show up your distance. Then you can comment this out. And then we can do the next one, the next while loop. I do this so I don't have to clear it out and retype everything. So we can say it, so in this while loop, if it's true, right, it's gonna wait for the object to be in range. If it sees the object in range, it's gonna print in range. If the object is out of range, it's gonna print out of range. So if you put your hand in front of it, you should see in range. And it doesn't take very long to really display that on shell. Okay. I'm going to replace my resistors on my circuit because I think it's not. Yeah, I had tested this earlier today and making sure everything works. And it did. And then when class starts, I'm also going to replace my cable. Okay, so let's bridge. I want to make sure I show you that it works. But if you already got it working, you can run it, take a picture of it. So I'm going to use the 330. Okay. You are going to go here. Okay, so let's try it again. Let me double check. Oh, son of a gun, it's working. It's the cable. All right. Okay, so let me share it. Okay, so earlier I had it with the other while loop, this one. Okay, so I'm gonna show you my shell. So you can see here that it's showing, I tested it also earlier today, you can see. It's showing like the value. So when it detects something, right? Like it's gonna go out of range, in range, out of range, and so on. So in range when you put your finger near it. So on this one, what happens is if you put your hand right near it, it's gonna give you the in range. Ah. Sorry, I just lost my thing on Raspberry Pi right now. But you get the point. So let's try VNC again. The world of technology, you know. Let me see if I can connect to it. Yeah, I know when for Zoom video, it uses one of the protocol and sometimes it creates a conflict. So it doesn't, it boots me out of the VNC sometimes. Okay. There we go. Okay, I'm back. Not need you anymore. Okay, sorry for a little slow right now, but the whole point in doing this is so you can see that your okay, your code works or your script works, okay? So now you saw how it shows me out of range, in range, and so on. And then if you wanted to stop it, okay, you can take the shell, you can close it. It's gonna say, is it still running? Do you want to kill it? Sure. Okay. Then we can comment out the second while loop. And then we are going to use the third while loop. And in the third while loop, this one, missing a thing here. This one uses two methods or functions. So we also have to define those. Now, in practice, you would see that you want to define your function for Python at the top because the bottom part is going to be your main, just like how you would write it in C or C++. So the way that we define a function in Python is to use the keyword def or def. And for this one, we would call it hello. You can call it anything you want. You can say nearby, not nearby. Okay, so the first one is going to be hello. That means that you have a person present in that area. And then we're going to print hello. And then we have a second function defined call by or method call by. And then we would print by to confirm. So we can use a while loop, okay? Or you can also implement an if-else statement. In this one, what I just wanted to make it easy for you, I would just put while true, ultrasonic dot when in range. So it's going to use this, which is a method, and then the ultrasonic is the object that we created earlier. And so if it sees it, then it's going to say hello. So it's going to execute the hello function. So we call on that function down here. And then when the object is out of range, it's going to execute by. So it's going to call on the by function there. Okay. So now we can go ahead and run this. Now it's having issues with my modules again. Okay, let's try it again. Yeah, I don't like this library for this ultrasonic sensor. I think next time I'm going to use a different library. It's having issues with accessing the child class on that one. Okay. So you should see hello and bye if it works. Yeah, this is just a warning. It's part of that. Sometimes there's a little lag with it. So you would see. Okay. I didn't have any trace back. It's just there's some warning for the module that we're using. So let's try. You can also edit this and you can bring it to 2 meters. So the value that you're using for the threshold is going to be the meter range. Also a way that you can test it, because sometimes certain IDE, it's going to give you this. You can use another IDE like it has Tawny. So let me try that too. Yeah, I'm getting like threshold right here. I don't like that. 0.3. Let me see. I'm gonna run it in Tawny and see. Let's take another look. I'm just gonna yeah, it had worked earlier. Okay, but anyway, um, so what we can do is we can also use a method with it, but yeah, it's I'm losing my echo signal again, as you can see. That's telling me that everything is working, but it's not getting my echo signal. So let me power it. So you can unplug the 5 volts, plug it back in, and then you can try to run it and see if that works. Any question? Yeah. See, there you go. You sort of get a little bit of that. So here, yeah, my stuff was just loose. So okay, so it's sensing me and it's not sensing me. Yeah, well, you can, for the sense, you can actually, it's tells you in the thing right here, Kevin. One second. So when you run that third while loop, you would get that. I think earlier I put 2 and I show you have to put 2.0 because it's going to take a float value. So yeah, so you can go to, you would have a cap on it. It tells you right here. So if you get like if you put a distance is 2, maximum distance is 2, it's not gonna like it. So yeah, I think you have to keep it under 1 meter is the max. So it's gonna tell you, it's gonna give you a traceback error for step K if you put the 2, because there's no, you can't go above 1.0. Okay, so you can try different value there. You can see for the threshold. You can change the max distance. So I'm going to change this to, let me stop on this side and then I'll go to this side. So that's the output. Let me go to the script. And then, so let's change this. So instead of threshold, let's do max. And then we can do 1, 1. So if you're getting like kind of the warning at the top, it's just because your sensor might be loose or your wire is loose, like what I've been having issue with. Okay. And then we can also, let's comment this out. And let's try the other ones again. So we can see if it's range. Okay. And then I want to comment these out. And since it's a while loop, it's going to keep running in the background, as you can see there. And then we can go ahead and click save. Or we can run it and it should save. So it tells me I'm in range. Okay, and this is my script. And this is not the only way, right? If you implement conditional, you can have it where you can say if else instead of just using the while true. So I had replaced this at the top. Instead of the threshold, I use max distance. And if you wanted to explore it a little bit more, I suggest you take a look at their documentation. There are sections on the documentation that you can take a look at. You can also find the source code on their repository, so you can see what was used or how it was written in the library, so you can expand on your script more. Okay. And in the warning, you see that here, it tells you where that is. Okay. So that might be something that they also added to the library, and for this, the packages is installed. It tells you the path there. Any question? Okay, so in this exercise, we build a circuit that uses ultrasonic. We also wrote script. The important part with using ultrasonic is to bring in the GPIO 0 library, and you can import in specific part of that library, which is distance sensor. You would then need to create an object. And so we called our object ultrasonic, and we would use that object to be able to access the methods from the library, which is what you see there. Okay, so in the distance sensor, you would see that we would want to specify our pins and then the value for our threshold distance, or the max distance. And if you don't have the third parameter, which is optional, and in Python, usually the third parameter is always optional, most programming language, right? Then it would just default to the maximum value that's in the default configuration. Okay. And so you can also use functions to be able to implement that with your script. You can have it inside a loop or in a condition. Okay. And so in this one, we mostly use while loop. Okay, any question? Okay, no question, huh? So this one is fairly easy. There are not a lot of wires. And so as you can see, sometimes it's a little bit slow after the warning. So just give it a little bit of time because it does have that time, you know, that it can detect. So it does take a little bit of time to receive that. Okay, no question. So if you're having issues with it, check your circuit connection. Make sure that you take a look at your pin connection. Also install the library if you haven't, or the module, that's what's called. Okay, next I'm gonna walk you through the LCD one. I think the LCD one have some issues. You know, I tried to troubleshoot some of it earlier, but when I got it to work earlier, it actually showed me like the text, but it could be my wiring, and I like went through it 5 times and I thought I had everything correct, but um, when I look at the code, there's also minor issues with it, but you get at least some of the procedure. Okay, so after this, let's stop share from here. Okay, so I'm gonna unplug this. Okay, so for the LCD, what you can do is you can, if you have female to female connection, you can do that. But if you don't, you can also adapt it. Okay, so 1 second, let me move my breadboard in here so you can see. Okay, so this is a potential meter. And if you don't have this, you don't have to do this exercise. It would have 3 legs. Let me grab one that's not plugged in. And those of you who already took the Arduino class, you probably know, but for those of you who haven't. Okay, so here's the potential meter. It has 3 legs. There's one in the back. That's gonna be your contrast, which is in yellow, okay? That one controls the brightness of the screen. Then the 2 in the front, the one on the left side is gonna be your positive. That's what's gonna be used to receive power. The one on its right here is gonna be your ground, okay? So the way that I did it, I just follow the diagram or the schematic. So the positive, you wanted to plug it to the positive channel here. And if you take a look at your breadboard, if you're not sure, right, you would see the label. The negative is the blue. So if you plug it in that column, that's going to be the negative. On the other side, that's the positive, so you want to plug the positive into that column. Okay, so here, what we're gonna do is we're gonna bridge it through the breadboard. So the ground is gonna go to the negative, the red, the positive, is gonna go to the positive channel. And then ultimately, we are gonna take one other cable and we are gonna plug that into the positive 5 volt on your Raspberry Pi. Okay, so now let's take a look at the next one. This one takes a little bit of time. LCD always is a little bit tedious. Okay, so as I mentioned, your trim pot right here is your potential meter. The yellow is gonna go to your D4, I believe. Okay, so what you can do with this is you would use a male to female, and that's what I did. I had used the yellow is the male connection here, and then the female connection onto the pin. Okay, and then on the next one, this is going to be for the data is the next one, and that's what you would see in blue here. And if you want to connect this directly onto the Raspberry Pi, you can use female to female jumper wire. If you don't have that, you can connect it to the breadboard and then bridge it from the breadboard to that. So I would use female, then the male here, and then the male to the female here. Okay. And then the same thing with this one. Now, when you started to plug these in, keep in mind that the front of the Raspberry Pi, the front is this way. Okay, that's where your first pin is going to be. So 5 volts is over here. Okay, don't think that it's over here because you got to take a look at these ports right here. So the 5 volts are in the front right here. Okay, and then after that is the ground. So when you plug that in, the 5 volt goes here, the ground. And what I did was I took this picture, I rotated, okay, and that helped me because it's the position of my Raspberry Pi is the other way. Okay, so the way that I have my Raspberry Pi right now is the 5 volt here, okay, and then the ground, and then you can go through and do that. Okay, so let's plug those in. So as soon as you plug in the 5 volt and the ground, you would see it turns on because now it receives power. But we're not done yet, right? The data is going to give you the text. And so what you would see is you would have to go through. And so I would start with the back, and then the back is going to be from top down like that. Okay. So and also another thing that you can use is this table right here. Okay, so it tells you that your LCD pin 1, the first one, is going to be connecting to the ground. That's on the breadboard. So that's on the negative side of your breadboard. The second pin on the LCD is going to go to the 5 volt, but that's going to be the breadboard 5 volts. So the positive channel, the red side. Then the third is the VO, which is going to be contrast. That's going to connect to your middle pin trimmer. So that's going to be your potentiometer middle pin. That's a contrast pin. Then the next is going to be your RS. And if you want to know what RS is, it tells you down here. So that will be register select. And this is where it's going to store the set data because it needs to be able to put it somewhere temporarily, and then it's going to be able to transfer that to be a data. Okay, so this is how you can get data from the Raspberry Pi to the screen. It needs to have a middle area where it's going to store it, so it's going to be the memory. Okay, so now it's gonna, if you understand the low level, like if you took assembly, we actually move one character at a time and you need to convert it, right? Because all of the output on the screen is encoded. So when you do that, what happens is as you move one character into memory location, it converts it into 0 and 1s, it digitizes it, and then when it outputs it onto the screen, it needs to convert it back using encoding system like UTF, ASCII most of the time, right? You would see that in ASCII and so on. So this is the area that's when it happens right here, okay, at the low state. So your RS, this pin is going to be doing that. That's pin 4. And what I had with the pin 4 was I had it with the blue, okay? And then I just have to find GPIO 7 or number 26. So when you look at your chart for your GPIO pin, right? 26, if you count, that should be 8 from the back. 2, 4, 6, 8. That's correct. So 2, 4, 6, 8. Okay. And then next to that one is going to be breadboard ground. So that's going to be RW. And for the RW, that one is a write mode. Okay. So it doesn't read anything. So it should be connected to the ground. It's going to be, you need to ground the right pin to prevent from it reading, because in the other pins, it's going to be able to read. Okay. So we're going to ground that one. So that will be the 5th on. Now, if you take a look at the LCD, most of the LCD would have it labeled. Then next one is going to be your E, and that's going to go to pin 24 or GPIO 8. So I have that one in green here. And so if you take a look, GPIO 8 is going to be next to yeah, so we have the 7 and then the 8, so they're next to each other. Okay. And then we're going to skip these. And so we're now going to go into the D4, which is pin 11 on the LCD. And this is going to go to GPIO 25 or pin 22. So as you start plugging them in, you should take a look at the screen. If it's not turning on as right, you can make the adjustment on the potentiometer, like turn the knob, and then see if you start seeing characters and symbols. Okay. Okay, so I plugged mine into 25, and then after that, we are going to go to the next one. That's going to go into pin 24. So we're going to skip the ground and we're going to put in the 24. And make sure that I'm putting in the right pin in the right column there. And then after that, it will be 23 and 18. So I have this. Let me double check. Making sure. 1, 2, 3. Okay. So now what you can do is you would then, let me switch share screen now. Okay. So you can open up your idle, okay, and you can copy and paste the code over, or what you can do is, let's open up terminal first. Yeah, it's better. Okay. So for the terminal, what we can do is first, if you read the instructions, disregard the change directory there. I checked the directory. So if you wanted to know where Python 3.7 is, I found it for you here. Okay, so you can start with root, and then in root, you would go to etc. And then in etc, if you go down, and you can use ls command to do this, you don't have to navigate. Okay, you would look for Python 3.7, which is here. So the instructions tell you that launch the terminal program, and then you would do a wget -o home py. And so there's a correction that's needed there. Okay. So instead of using HTTPS, it's not going to be able to interpret. Sorry, my internet is unstable. So let me stop video real quick. So when you're using the wget, O is going to stand, it's an option for output. What it's going to do is it's going to output this file in your home directory py, and then this is the file name. So this is a way for us to really pull, right, file from a website. Okay. Then you are going to put the www dot, and this is the website that we need to get, and files, and then LCD. Now, if you wanted to visit the site, you can simply just copy this and then open up the browser. And then you can find a file there. Okay. So this is the file. And so when I had copy and paste it over to Microsoft Word, the indentation and things were lost. So what you can do is you can do Control-Alt or select everything and then copy it and then put it into your idle if you want, and then you can run it. Okay, so I'm gonna go ahead and try that right now instead of using the file, and then I can show you the other way. Okay, so this is why we're pulling the file from the terminal instead of, you know, typing out everything, because it's quite long and sometimes you can also make mistake. Okay, so we are going to copy, and then also keep in mind that when we pull it from the web, sometimes the application translation of it can get lost. So I'm going to go ahead and go a new file, and I can close this one, and then I'm going to go ahead and paste it. Okay. So now I have the code. If I don't want to run the wget-o and then put that into, now when you run the wget from the website like this, okay, what you see is it's just going to drop it to the next line. That means that it worked. How do I know that it worked? Go to your file manager, and then you see all of these that I tested. Go to your home and Pi directory. That's where we place it right here. So you're going to go to the folder, and then you're going to go to your Pi directory, and you should see the file, this. Okay. And when you double click it, it might default to Tony to open it, and so on. Okay. And then you can take a look at your LCD. If your LCD is working, then you can check, right? Now, if you copy and paste the file over from their website, just gotta make sure you save as. Okay, and then I'm just gonna call this test lcd.py because I already have look, can you guys see? It says I love my RPi. Maybe I should stop share. So your output, it's the camera doesn't show it, but it should show text. It says A, B, C, D, E, F, G. I love my Raspberry Pi. If everything works, if your LCD is not showing text or it's not bright enough, you adjust it. Yeah, mine's a little loose, as you can see. Okay, so press the potential meter down, and then also check your connection, making sure that that works. Okay. Okay, any question? So now we should have a working LCD. We have a working circuit with ultrasonic. If you attended all four, and we also tried the PIRA yesterday, and we also tried the LDR or the photoresistor yesterday. Okay. And if you wanted to tweak your display, you can go back to the code or the script, and then you can modify your text output. Okay. So there are two ways to do that. You can download the file, or you can um, go to the website and copy and paste it, so it's easier for you. Now take out, when you run the terminal, I'm going to show you again so you don't get confused. Don't use the HTTPS. Okay. So in your terminal, it will be like that. So we want to use the wget with the option O, which is for output. It's going to output the file in the home, the Pi folder inside the home folder, or the Pi directory inside the home directory. And the last part of it is the actual link to where that file will be on the internet. And then once you got that, then you would go to your Pi directory and you would find the file. You can double click it, or you can use idle to open it up and then run it, and it should work for your LCD. Okay. Let me highlight that so you can see. Any question? Okay, no question. Okay,
Dr. Wen?
so yes.
Oh, I'm sorry. I'm
That's
just
okay.
I'm having just a little bit of trouble with I don't know, I think just the whole GPIO, just the pins. I look at the reference, but I feel like I'm doing things wrong.
Which exercise are you doing?
Well, I'm still on the week one, the day two one,
Uh-huh.
the 3 different types of resistors. And I don't know
Okay.
why the LED is not blinking. I just taken them all out. I'm trying to redo it from the top, but I'm not sure what's going on.
Okay. All right. So let's.
But I don't know. I can always go over it after.
That's okay. Does anybody have any question on the current project before I answer Cynthia's question while you're working on your LCD? It took me a little bit too on the LCD, just having to figure out the wire, but once you have it working, it should be showing, A, B, C, D, E, F, G. I love Raspberry Pi, all of that scrolling text. Okay, so lab 1. Are you referring to assignment 1?
Yeah.
The LED, right?
Hmm.
Yeah, I think I wrote back to you because when I looked at the picture,
Uh-huh.
your
Oh,
yeah, let me
let me
share
see.
screen and tell you why. When you plug things in, make sure that the legs are lining up, because your current is gonna flow across. Okay,
Okay.
so when it's getting, so this is the 5 volt, right? And so when you're taking a look at your chart,
Mm-hmm.
the 5 volt, the 5 volt is going to be the way this is drawn. The front of your Raspberry Pi is this way, so the 5 volt is going to start here. Okay,
Oh, okay.
and
I'm
then the
sorry. I can't
next.
see.
Okay, so the 5 volt is going to be the right pin. So if you see the Raspberry Pi symbol, that's
Yeah.
the front of your Raspberry Pi. Okay, and the
Okay.
front of your Raspberry Pi, so the first pin in the second column, the farthest column, the right column, is going to be the 5 volt. And then the third pin down from that is, or the third pin from the top is going to be the ground. So the way that the wire is connecting is the green one for the LED exercise is going to be connecting to the ground. That means it's negative. Okay. And
Mhm.
then that wire needs to be lined up with your resistor, and you can use 330 or 220. That's fine. Um,
Okay.
so make sure that that wire is right across, right next to the leg. So when I looked at the picture, the thing is that you're not lining up the leg with the wire. So your resistor leg needs to go to the next hole on the breadboard, on just like how the picture is shown. They put little green dots there for you just to indicate that it needs to really flow on the same line. Okay.
Oh, okay.
And then on your LED, the curly leg on the right is the long leg, and the long leg is always going to be, um, so that one, if you take a look at how it's connecting to the yellow, so that 2, 4, 6, if you count that down, 2, 4, 6, that's also a ground. Okay. So those cable needs to go to ground and ground, and you can plug them into any ground. Really, there are like 4 or 5 different grounds on the Raspberry Pi.
Mhm.
So those wires need to go to the ground, and then the resistors. Wait, let me double check. 1, 2, yeah,
Oh, I see.
yeah.
Okay.
Oh, I'm sorry. Yeah, the first one is gonna go to the ground, and then the yellow is gonna go to GPIO 18. Okay. So
Oh, okay.
GPIO 18.
Okay, thank you. I'm sorry about that.
The way the yeah, it's okay. I get confused too, because sometimes people would tell you in the instruction that it is this pin number. Pin number doesn't mean GPIO number. So
Uh-huh.
on the Raspberry Pi, that is pin 12 GPIO 18.
Oh, okay, okay. Thank you so much.
Okay?
Yeah, yeah, that
The
makes sense.
yellow. Okay? And then that needs to line up with the longer leg, and then the shorter leg needs to line up with your resistor. So what happens is it's gonna flow, right? Because the shorter leg is the ground through the resistor, and then through the ground connection of the Raspberry Pi. It's all like zigzagging connecting, right? And then
Right.
the data is gonna connect to the long leg, and that's gonna be for GPIO 18. How can you also tell which GPIO it is? When you read the script, it shows you the definition of the pin in there. It says LED is equal to 18. That's the GPIO number. Okay.
Oh, I see. That's the GP. Okay, yeah. So that's the
Yeah.
GPI
Yeah.
in one.
The way Raspberry Pi is used, the way they made it, is there's pin number, which is different than GPIO number. GPIO number will always go into your script, will always go into the code. Okay.
Okay, perfect. Thank you. Sorry.
That's okay. Are there any other questions? Okay. No question, huh? Okay, so the LCD, we worked on that, right? Make sure that we wire it up if you wanted to attempt it. And you don't have to have female to female connection. You just have to make sure that you bridge it. Okay. Albert already typed in his name. So before we leave, right, I want to preview you for tomorrow, what you're going to be doing. And you don't really need your Raspberry Pi to do Sonic Pi, but and other application as well. You can do them outside of it, but we will use the Raspberry Pi. Okay. Um, that's okay. You can just that's fine. Well, what we're gonna use is we're gonna use Sonic Pi. So if you have the OS install, let me unshare from this side. So tomorrow, for tomorrow lab, you are going to use two type of applications out of the four. Let me open that up so you can prepare. Now, when I do this for Sonic Pi, sometime I would, okay, I would I would tell the student that if you have a powerful Windows or Mac system, it works faster. Just keep in mind that when you start using RPi with things that is heavy in memory usage, it's gonna slow down a little bit. But we are gonna use one of the options that you can use is your Sonic Pi, okay? And your Sonic Pi is under the programming. I'm going to show you the one that's on Windows PC, and so you can have a taste of it for tomorrow. Okay, so you can install this on Windows. Also, it doesn't work with Chromebook though. They don't have a version for Chromebook, so but there is a version in Raspberry Pi, so you can use that if you have Chromebook. Um, you can also use Mac, so you can visit the website and be able to download it. So the interface of this is going to look like this, and we're going to go through the code tomorrow. I'm going to walk you through how to really make some of the beats, and then you can also see the interface information in the actual lab. Okay, so all together, I'm using just sample that is pre-built synthesizers or sound that came with the actual application, and this is written in Ruby. So once you have that, let me share computer sound so you can hear it. Okay, and sometime when I do this, it does take me off of Zoom, but let's run it. So it tells you which line it's running there. See that? Okay. So you get the idea now. So we will actually add in different synthesizer, and then, or you can actually play a song like this. So you can see that you can actually play the notes. And then if you want, if you make your song, you can actually record it and it will just store it to the device. You can also save your code. And then if you check out some of their online resources, Daft Punk, some of the DJs, they're musicians that use Sonic Pi for, different shows and different things like that. Um, Dr. Sam Aaron, he's really into music, and he was the pioneer for this project, and I'll talk a little bit more about him tomorrow. Um, so you can do, so each of these can be your track or your song, right? So, and I have code for these added to your lab exercises, okay? And you can do like adjusting tempo and stuff like that. Okay, adding in different sound. Now, it does have the help options. So if you visit their website, or if you go into the help option of the application, it walks you through as well. There's tutorial that's built into it, so you will be able to use it. So this is what we're going to be doing tomorrow, along with option 2 for you tomorrow will be, sorry, Sonic Pi is always so long, we are going to talk about Flask and SQL Alchemy. I know some of you already took my class with Python networking where we worked a little bit with Flask with SQL Alchemy, but this one kind of show you on how you can create a little web server. There's some very basic though. It's not a full blown website, but you will have your local website. Now, if you wanted to really host it from your house, you have to contact your service provider and make sure that, and then you got to enable port forwarding, and then you got to allow DNS service. There's a lot more configuration on the networking side to it. And then also, linking your database to it and so on. But what we can do is we can just make your Raspberry Pi a little server. And so, if you use its IP address, once you have it enabled, you will be able to see your web page, or the pages that you include on that web server. Okay. So web servers are just systems, and you can use your regular PC with IIS services. There are different type of web services for different system, but so it walks you through, and we'll talk about Decorator and how to really use Decorator, especially when you're using it in this sense for the web services. And then we can talk about like your hosting IP addresses. So it's just going to use your host address, which is going to be your Pi address or your loopback address, to be able to pull up your pages, which is your 127. And then we'll talk about port number. So this gives you a little bit more understanding on a little bit on the networking side and a little bit of web development. Some of you already probably took HTML, CSS, but if not, this is a good opportunity to kind of get a little brief overview for it. And then I'll talk about frameworks and how frameworks is used. And then, so this will be what we will be doing tomorrow. Okay. And just a little bit different from the Linux side compared to Windows is that, the concept is if you keep your index pages, your index and all your pages together in the same directory, it works across all systems. But on the Linux side, you can run the terminal for a lot of the purposes. But we're just gonna write the script for this and then be able to open the pages. So it gives you the tutorial there. Okay. And then the last day of our class, then we will start working with um, Minecraft, Pi, and then the option for the last part is going to be GUI in Python, which is a little bit elevated from your regular Python programming. Okay. Any question? Okay. So what I want for the assignment, if you have completed, is going to be 3 pictures from 3 exercises that you chose, right? It doesn't have to be all 4, and you can upload those pictures and submit it. If you're not done with the assignment, you have until Sunday to complete it. Everything is due by Sunday because that will be the last day that this class will close. And so this is our last week because it's only 2 weeks. Okay. So we will have tomorrow and Thursday that will be for Raspberry Pi. And then in the Design IoT one, if you're taking that one with me, I will touch on Raspberry Pi Zero, how to work with Raspberry Pi Zero W. And then your option can be this, or if you have Arduino already, you can use Arduino for your IoT projects. But Arduino might not work well because it doesn't have internet connection. Okay. Any question? Right, I see okay, type your name into the chat. I'll stick around for about an hour so to help you if you have any problem with your circuit or code, or
I
have a
have
good
a
afternoon. Video will come up.
question. Um, Hello? I have a question.